Hey guys, it's Mrs. Bryant. Welcome back to Flip Video. I need you to press pause and make sure you have gotten the notes out that I gave you in class today. Once you have notes ready to go to watch the video, you can press play and we'll resume. Today we're going to talk about direct variation and proportional relationships. We have already talked about proportional relationships when we were talking about the constant of proportionality, but today we're going to talk about how they are related to direct variation. So let's begin. The table below shows the relationship between the input signal power of Eric's amplifier in watts and the resulting output sound intensity in watts per square meter. It says, does this situation represent a proportional relationship? How do you know? Remember, first step is to find change in Y divided by change in X. So change in Y divided by change in X is going to be 2.25. 3.75 to 9 is going to be 5.25. And 9 to 10.5 is 1.5. Then do your change in X. 2 to 5 is plus 3. 5 to 12 is plus 6. And 12 to 14 is plus 2. So, change in Y divided by change in X equals 2.25 divided by 3, 5.25 divided by 6, and 1.5 divided by 2. So if you do your calculations, you should get 0.75 each time. So we know it is linear. Now let's check to see if it's proportional. Proportional is Y divided by X. So 1.5 divided by 2 equals 0.75. 3.75 divided by 5 is 0.75. 9 divided by 12 is 0.75. And 10.5 divided by 14 is 0.75. Because Y divided by X is equivalent to the change in Y divided by change in X, we know that it is proportional. So, if the relationship is proportional, what is the constant of proportionality, or K value? Remember, we already figured this out. Y divided by X equaled 0.75, which is also known as your K. It says, write an equation to show the relationship between the output sound intensity, Y, and the input signal power, X. Remember, Y equals KX. So Y equals 0.75x. And this should all be a review of this weekend's video. So graph the relationship. What do you notice? Well, we know that input is input was 2 and we needed to go to 1.5. 5 and 3.75. 12 and 9. And 14 and 10.5. And if we had 0, the output would be 0. So what do you notice about this graph? You notice that it starts at the origin. And we know if it starts at the origin, it is proportional. The situation represents direct variation. This is a word you need to know. Where Y varies directly with X, because Y divided by X is the same value for every row at the table. This you need to know, because when Y varies directly with X, you need to know that it means direct variation. The equation for a direct variation where Y varies directly with X is Y equals KX, where Y divided by X equals K, and that's a review of Monday night's video. But you still need to review it and you need to know it. In a direct variation, the K value, or constant of proportionality, is known as the constant of variation. Some more vocab that you need to know what it means. So the graph of a direct variation where Y varies directly with X is a straight line that passes through the origin. More information that you need to know right here. So the table below shows the widths and the lengths of the United States flags. Determine whether the data set shows a direct variation where Y varies directly with X. If so, write an equation that describes this relationship. we know that it has to be linear in order for it to be proportional. So all we have to do is y divided by x. So 0.95 divided by 0.5 equals 2.375 divided by 1.25 equals 3.8 divided by 2 equals 8.55 divided by 4.5 equals, and 45.6 divided by 24 equals. Use your calculator to figure those out. Press pause while you're doing it, and then check your answers when you're done. Once you've done the math, you can see that all of the expressions or equations came out the same. So you can say your k is equal to 1.9, or your constant of proportionality is 1.9. Now, to write the equation, remember it's y equals kx, so plug in what you know. Y equals 1.9x. We know that we can use this equation anytime we need to figure out the length of the flag if we're given the width of it. The minimum amount of time it takes a driver to ascend safely to the surface of the water varies directly with the depth of the water. Write a direct variation equation for this situation. Well, start with your points. Origin, 0, 0. Then we have 60 feet and 2 minutes. Then we have, that's going to be 150, so that's probably about 140. We're going to go with the ones where it crosshairs. 180 and 6. And 270 and 9. So, to figure out our process, remember we need to find our change. So that's plus 2, plus 4, plus 3, plus 60, plus 120, plus 90. So now, 2 divided by 60 equals 1/30. 4 divided by 120 equals 1/30. And 3 divided by 90 is 1/30. So our process so far is x, so 1/30 x. So 1/30 of 60, so 1/30 of 60 equals 2, so we know we're not going to do anything. So that's going to be our equation. So y equals 1/30 x, and there's your equation. Then use this equation to predict the amount of time it takes to ascend safely from a depth of 450 feet. Your depth is your x. Notice it in the table. So we have y equals 1/30 times 450. Use your calculator or do the math. Multiply your fractions. 450 divided by 30. Those cancel. So your answer is 15 minutes. Okay, so how does the graph verify that this is a direct variation? The answer would be that it starts or passes through the origin. Okay, the next question says, how does the table verify that this is a direct variation? If you look at the table, you have 0 for x and 0 for y, which is the ordered pair 0, 0, which is the origin. And how does the equation verify that this is a direct variation? It does not have anything added or subtracted. So that means it's multiplicative. Alright, so when you come into class tomorrow, we will figure out the foldable and do it together so you have a live version of an example. So until then, make sure you do the video survey and answer all the questions involved, and I will see you in class tomorrow. Have a good night.